Okay guys, so with your quizzes for 2D forces and inclined forces, handed them out on Friday. You can get an answer key from me and copy out the answers so that you have a clear understanding of how to do it if you got stuck on any of those questions. So please take advantage of that. So today we are going to do our inclined plane notes. And the first practice problems we're going to do is the one that is just the one-sided sheet. So just the first assignment problems. That's what we'll start with. Okay, so just a little quick review of our inclined forces, how we drew our free body diagrams. So recall when dealing with inclined forces, so this is pulling something across a horizontal surface at an angle, that it is important to break all forces down into their x and y components, and then create a horizontal force net equation and separate horizontal force net equation. So we're always looking for our force net. So when we did inclined forces, we drew our object, put our circle in the middle, and then we had, since it's an inclined force, it's going at an angle, and this was F at an angle. Okay, and since that's going at an angle, we need to break it down into its two components. So we said going to the right here would be F at x, and here is F at y. If this is tension, which normally it is with these, this would be Ft, Fty, and Ftx. Or F is fine too. Always opposing the direction of movement. So here is d of m for direction of motion or direction of movement. Always opposing the actual direction of motion is our Ff. The perpendicular to a surface, so we're assuming this object is moving horizontally along a surface, the perpendicular force is Fn, and we have our Fg. So that's just a recap of inclined forces. Then we started doing inclined planes yesterday, where you had your lab, and you needed to draw your free body diagram on your lab. So we are now going to look at problems that deal with inclined surfaces. So surfaces at an angle, or this is called inclined planes. Instead of using our common labels of horizontal and vertical forces, force net equations, it's easier to consider force net equations that are parallel or perpendicular to the surface. So that's why yesterday we broke down our gravity into perpendicular and parallel. So let's say here's my actual surface. This is the angle of the surface. And then draw your object like halfway up. So what we're going to do first is when the object slides down the incline. This is the first kind of thing. Object sliding down the incline. So if the object is sliding down, it doesn't have any F at. Okay? But what I'm going to do first is draw my direction of motion. Overall, if it's sliding down, it's going to be obviously moving down the incline. Again, my definition of FF is it's opposing the direction of motion. So my FF is going back. Fn is perpendicular to the surface. So here's the surface, it is perpendicular. Now, Fg is a bit of a trickier one here. If we're going to draw the force of gravity coming out from the middle of our object, that still goes straight down, because the force of gravity is pulling the object to the earth. So this blue vector that I just drew in here, this is overall FG. But now our FNs, FFs, and FGs are they're not all horizontal or vertical. And that's harder to work with. So what I do now is I break down my FG into perpendicular and into parallel vectors. So now coming out here is FG perpendicular. It is perpendicular to the surface. And then you draw a line connecting, another vector connecting, and this is FG parallel. It is parallel, or more or less. My diagram's not perfect.
How come you didn't make like a right triangle?
It is. It's just not super awesomely drawn.
Oh.
But this is a right angle right here.
Okay.
Yeah. So you can draw that in that that's a right angle between FG parallel and FG perpendicular. And then when I look at this angle here is also theta. That's the angle of the incline. So this theta is the same as this theta. Now on my overall diagram, I'm just going to say what FG parallel is one more time, but I'm going to draw it up here. I can say that this is FG parallel. So it's the same arrow right here as right here. I just drew it right on the object just to show my free body diagram more clearly. So this is all the object sliding down. So now, when we find our F-nets, we look at F-net parallel and F-net perpendicular, which is essentially what we think of as like, this is our kind of our y-axis, and this is our x-axis, because it's like this is kind of our horizontal and that's our vertical. That's how we kind of think about it. So we can just, tilt your head. Okay? So when we're doing our F-net equations, which color should I use? Okay. We have F-net parallel is equal to, so now I look at everything I have parallel. I have FG parallel and FF. So I have FG parallel plus negative FF. And it is negative because it's opposing the direction of motion. So then we can rewrite this as F-net parallel is equal to FG parallel minus FF. So that's kind of a good formula that we use for objects that are sliding down. Then we find there might be cases where you need to find F-net perpendicular. So now I look at everything that's perpendicular, and that's Fn and Fg perpendicular. So this is equal to Fn plus negative Fg perpendicular. Again, I can simplify that. Oh, one more thing. When an object is sliding down, is it moving up or like down this way? It's just sliding down the incline. So it's not floating up or falling. So we can say F-net perpendicular is 0. The only actual movement of the object is F-net parallel. So when we're trying to find like acceleration, we need to find F-net parallel, because that's the actual motion happening. Anyways, okay, so I've set this to 0, so now I'm going to rewrite this as if I rearrange it, if I bring my FG perpendicular over here, now it's a positive. So I say FG perpendicular is equal to Fn. So those are the two formulas for objects sliding down. Are we good with this one? Any questions?
So why is F-net 0?
For here?
Yeah.
Because this object is not actually moving up into the air or or falling down this way. It's only moving in this kind of horizontal direction. So FNet perpendicular means up or down. Yeah. Because it's like we turn our head sideways and we say this is the horizontal and this is the vertical. Okay. So that was part 1.